we have Kory Draughn. Kory Draughn that is connecting from the US. Kory, can you hear us?
Yes, I can. Can you hear me?
Yes, loud and clear.
Excellent.
Thank you. Thank you so much for connecting so early in the morning. But basically, I would just leave the floor to you, just not to, consume other minutes, basically for this interesting overview on iRODS.
Okay.
Thank you.
Thanks, Mario. Let me just get my slides here. And let's see, I'll start video. Can people see me? Am I visible? All right. Okay. Let's see. So, yeah, I guess to start off, my name is Kory Draughn. I'm the Chief Technologist for the iRODS Consortium. I'm very happy to be here to talk about protocol plumbing, what that means in the context of iRODS. All right, so I guess first off, a bit about the iRODS Consortium. It's an organization that is operated and managed out of RENCI. RENCI is a short name for Renaissance Computing Institute. Is one of many research institutes here at the University of North Carolina at Chapel Hill. Here we have a slide showing people who make up the iRODS Consortium. These are people who support the iRODS software project, and they depend on it. They use it for various different things. These tend to be people who are these are integrators, people providing various levels of support, people doing science, and as well as people, storage vendors who are looking to sell into those locations. All right. So the consortium's main goal is to grow the community. We want to continue to grow the software, make sure we work on it and improve it so that it meets the needs of our users, as well as provide standardization. That means essentially, things that can help many people. We tend to work on providing generalized solutions and standards around how something should be done, so that it's not surprising to everyone. Let's see, and then of course, for people who do join as members, we want to show value through our membership. Our business model, iRODS is maintained through a sustainability model. This is so all of the software that we work on is done in public. It's open source. You can go download it today and use it. But if you join as a member, then that means now you get a chance to, you come in at some level of support. There's 4 levels, and with each level you get some number of hours and support, which allows us to have conversations around proofs of concepts, troubleshooting. You can ask questions, just anything that comes to mind. This also gives you the ability to participate in the direction of the software and have a vote in what happens next in its future. All right. So a bit of history about the iRODS Consortium and the project. iRODS has been around for more than 20 years. It's a very mature project that's still being worked on and improved. We're approaching 50 releases, I believe, to date. We just put out our latest 4.2.12, which is the last version within the 4.2 series. And now we're going to be shifting gears to iRODS 4.3. It's a lot of nice things that's coming down the pipeline for that. So why do people even use iRODS, right? Well, people tend to use iRODS because they run into issues such as they have a large amount of data, and now it's becoming very difficult to manage this data. This data could be stored across various different storage technologies. And, administrators and companies, they want to be able to control who can access this data, through various different means, whether that's through a permission model, whether there's through some other scheme. They may want to apply some automation around their data to get humans out of the way. Like if they can box it in and automate it, then that's just one less area where they have to think about as far as issues cropping up, right? They also, when you have large amounts of data, you typically want to have some kind of search facilities that are efficient and allow your users to quickly find what they're looking for so that they can do the science and do their job. Now, obviously, the larger your organization is, the more you need software like iRODS, right? So you may be wondering, like, where does iRODS sit if you have some existing infrastructure? Well, the good thing is that iRODS it works with your existing infrastructure. You don't have to change anything with your environment to get iRODS up and running. You can choose to put all of your things under iRODS, or you can choose to only, put a subset of things in your environment under iRODS. The thing to keep in mind about iRODS is that we view it as a platform. This is not that there is some learning involved around the use of this tool, but once you understand the concepts and the mental model around it, things become really easy and you start to see the power and what's available to you. One thing that I haven't mentioned here is that iRODS provides an abstraction layer around your storage and various different technologies. And so people who deploy iRODS, they typically have clients, and they end up developing clients and additional tools, or they can use some of the ones that's offered by the community and that's available via open source projects. And this removes the need for users to have to know what storage technology they are dealing with. For example, you might have tape, you might have some normal hard drives that are just laying around that you also depend on, and iRODS can handle all of these things. And to the end user and to the developer who's building software on top of iRODS, they don't have to deal with the different technologies underlying it. And so this gives people who are managing this infrastructure flexibility to change things over time. So iRODS provides these things called capabilities. These are packaged and supported solutions. These are things that have been developed due to a need by the community. People have reported, some people want storage tiering, some people want a way to ingest data in an automated way, right? And so as the consortium, our job is to provide generalized solutions that can benefit everyone within the community. And so here in the little picture below down here, we have 8 different capabilities that are built on the foundations of the iRODS platform. And all of these are either they leverage metadata in some way, or they might use various other facilities provided by iRODS to achieve their goals. But this is the main thing to take away from this, is that these package solutions are designed to be an install and configure and you're done type of thing, right? There's no code that you need to write to make these work. You simply install the package, configure it to meet your needs, and you're done. So this is kind of going off of what we've already discussed so far. This right here is image. Mostly people who come and seek us, they normally need 1 or 2 things when they start off. That can be things such as auditing or storage tiering, right? But over time, as they become more comfortable with the platform and they learn more things and they become more confident and they build up confidence through success in using the platform, they typically branch out to using other things such as automated ingest or indexing. They might want to build some piece of software that helps with compliance in some way. So now that we know or have a better understanding of what iRODS is, we can get to what we mean by protocol plumbing. So iRODS, the ecosystem around iRODS has continued to grow over the last few years. It's always expanding. People always have new needs. But the challenge, especially for new people, is that iRODS implements its own protocol. And so this means that it doesn't, the protocol itself is unfamiliar to newcomers. And so we want to get away from that. We want to improve the situation around approaching the platform altogether. Not only that, but we also want to make it where is that people can leverage that for those cases where people don't necessarily want to learn a new system, they can interact with an iRODS system um, through using their existing tools and things, right? And so protocol plumbing is essentially about building shims around the iRODS protocol, right? We on one side we speak one protocol, and on the back end, this protocol is translated into the iRODS protocol in a way that is expected. It produces results that are expected by the end user, right? So in this talk, we're going to cover 7 different protocols here. One thing you'll notice is that as we go through these protocols, not all of these, many of these are implemented by people within the community surrounding the iRODS platform. And that's exactly the kind of thing that we want. We don't, the consortium does not want to be responsible for having to build every single solution that comes out. If we can build tools and things that enable developers and teams to do what they need to do, then then we're in a good spot. All right, so first up is web dev. So out of the University of Utrecht, they have designed and developed a project called DAVRODS, which allows people to, it's essentially a C project. It's implemented using the C programming language, and it is an Apache HTTPD module that people can just install, and then they get support. They get the ability to view things and interact with an iRODS system through the web dev protocol. Right. Our next protocol is Fuse. So Cyverse is an organization that is operated out of the University of Arizona, and they maintain a project called iRODS FS. This is a Fuse implementation using the Go programming language. Cyverse has implemented an iRODS library that allows people who use Go to interact with iRODS systems. And so they have this is their second generation of the Fuse client. And so users can deploy this and they can gain access and speak to an iRODS server using the Fuse protocol. Okay. Next here is REST. So like REST is more so the HTTP protocol. Obviously, HTTP is very flexible, and so it's taken over the world. Practically everything uses HTTP, and so we really wanted to look at providing and presenting iRODS as HTTP as well, right? It's going to be, if you can support HTTP, then that means practically any programming language can also interact with the system, right? We don't want to require everyone to use C and C++ or some programming language specific implementation of the iRODS protocol, because there's differences there. So the consortium itself is developing and maintaining an HTTP/REST API. And so this is going to be targeting newcomers and people who are unfamiliar, but they need to build things quickly that can interact with an iRODS system. When this talk came out, this was the second generation at the time, and now we are now in the third phase, and we are now rebuilding this from the ground up based on things that we've learned from our community members who are using the REST API. So hopefully this third implementation will prove to be the one that satisfies all the needs of users within the community. Our next protocol is NFS. This is a Java-based project. It leverages the NFS for J project that's developed by Dcache. Essentially, the consortium has implemented a virtual file system module for the NFS for J project. And so if you deploy this is like many of these are simply iRODS clients, all of these projects. Some are, drivers or whatnot, but for at least the majority of them, they're all clients to an iRODS server. But what this does, it allows iRODS to be presented as an NFS 4.1 server, which essentially allows people to mount an iRODS space, mount an iRODS collection, and expose that through NFS. And then people can just use whatever scripts they have that they've been using to interact with the server without even having to know that they're talking to an iRODS server. Next is yet another project that is maintained by Cyverse. That is SFTP. So they forked a project called SFTP Go, which is a Go-based, which is a project which uses the Go programming language to provide access to various different storage technologies, whether that's a local file system or Google Cloud storage or whatnot. And so what Cyverse has done, they have, on top of all the other things that SFTP supports, they have developed a module for the SFTP Go project, which allows iRODS to be exposed via the SFTP protocol. And one thing that I've not mentioned so far is that as far as Cyverse, everything, and the University of Utrecht, everything they're doing, they're using in production. So these are not experimental projects that they've just built as an exercise. These are actual things that they are using in production environments, and they have several thousands of users who interact with these systems daily. All right, our next one is Kubernetes CSI driver. This is for people who are not familiar with container storage interface. This is all about essentially Kubernetes type things. So this is container orchestration related. In this case, Cyverse has developed a CSI driver. This is a specification that allows various different container orchestration engines to be leveraged, or you can provide storage and possibly you can provide storage to your container orchestration space. And so again, this is something that they use in production and is doing very well for them. Our last protocol here is S3. So for a long time, iRODS has been able to speak and interact with S3 storage. And so that means that you remember the slide where I was explaining the abstraction layer. iRODS abstract storage technologies. S3 is just one of those type of storage technologies that iRODS supports. And so for many years now, iRODS has been able to speak and provide POSIX-like semantics on top of the S3 protocol. What we're doing here, as you've already been seeing so far, is that we want to present iRODS as the S3 protocol, right? There are many people who, S3 is a very popular storage technology. It's very popular, has several different clients. And so if we can make iRODS present as S3, then that means now all of these clients can now interact with an iRODS system. And one thing I didn't mention here is that also that this is a project that is maintained by the iRODS consortium. It's still in early phases, but we expect that within the next few months, perhaps, we'll have something that we can actually people can get their hands on it and at least experiment with. So with that said, what have we learned here through our experience of working on these things, as well as our users trying out these things? We know that shims are never perfect. There's always I wouldn't say always, in many cases, there is, you can't support all the features that are provided by iRODS through the other protocols, right? NFS, for example, is a protocol. It doesn't support metadata in the same way that iRODS supports metadata, and so that's just a thing that people who use NFS rides or the NFS project, they know that they cannot leverage metadata facilities through it, and that's not a bad thing for them. It just means that they have to use some other tool for that if they ever need to be able to do metadata related activities. Also, there's still value in doing all these things, even though the shims they don't align perfectly with the all the features that are provided by iRODS. There's still value and it's worth the effort. We learned a lot of things, and obviously with protocols, because they tend to move or not change very frequently, once they're stable, maintenance is very minimal. As for future work, we want to continue to expand on the number of shims that are available to users. We want to improve the ones that we have, and we want to continue to make those stable and keep up with the changes with the protocols. And if there's some that people feel would be very beneficial to having for iRODS, then we're open to hearing about those situations as well. I guess last but not least here, our final bullet item is that the HTTP API, the REST API, we are considering making that a native, bringing that into the server, essentially. And this is because HTTP is just very easy to deal with. Assuming, like, if the community grows to adopt and shift towards using the REST interface, then it makes a lot of sense to just offer that as part of the out of the box with an iRODS deployment. It just makes approachability for newcomers better. Okay, so we have an annual conference that we hold every year. This year is going to be in Chapel Hill. You can see the date here is from June 13th through the 16th. Here we offer training. We give presentations, and those presentations are not only from the consortium, but also from people within the community. And we also have a troubleshooting session, which occurs. If you're interested, please register, join us. We'd love to have you. This is both in person and virtual. So if you can't make it, then there's always the virtual option. If you want to know more about any of the things that's been discussed in this talk, then all of this is available at iRODS.org. You can reach out to me, and I will provide you with as much information as I can. With that, that wraps up this talk. Thank you.
Thank you very much, Kory. Yeah, as usual, is there any question for Kory about, what he presented on iRODS, and especially the fact that he gives this nice overview on how accessible the code is for us, for our community. So I really appreciate that. I think it's very hands-on for us as a perspective. Any curiosity, additional question for Kory? If not, Kory, I would like to ask you one thing, which is less technical, more sociological, let's say. Do you think it would be welcome for iRODS to liaise with the community that in our domain are dealing with containers and Kubernetes? And because I've seen your CSI, you mentioned the CSI work. I was wondering if how would that work if you welcome, let's say, that communities could be part of a POC or reaching out to you in general, what do you think would be the best way to support this community effort from our side?
Well, I'm not sure I understand the question all like fully. Are you? Can you rephrase it?
I wanted to ask you, how can we, let's say, be useful and help with respect, for example, the work that you mentioned would be a POC proof of concept implemented, welcomed by iRODS as a consortium, or to liaise with the community? Do you see room for further liaising with the community that we represent, so the research and education networks and related institutions?
Yes, yes. We have a Google group which is open to anyone. You can post questions there. You can reach out to support. We can have further conversations. We're always open to having conversations with people who have a use case that they need satisfied. We are, for people who know about iRODS and who have been using it and have questions and want to run ideas by us, you can always join as a member, and then you get actual dedicated support hours depending on your level of membership. But again, people can open issues. All the things that we work on are done. It's in public. It's on GitHub. You can open up issues. We see people ask us questions in various different ways, and we'd love to have more conversations around that.
Thank you. Thank you so much. Let's thank our speaker again. Thank you, Kory.